So let me introduce myself. My name is Piotr Gołkiewicz. I'm based in Poland, not far away from you. And I'm customer success consultant. That means I'm responsible for making sure you are happy with our life science products. In this case, it's mostly Reaxys, but we also have other products like Chembase and others. So because it's my job, then here you see my email address as well, and please feel free to contact me anytime you have any troubles with Reaxys, including access issues, but also, and mainly, I think, usage questions. So don't be shy. If you need any support, you try to find something, you don't know how to do it, please let me know. So that's my job, and that's why it's a standard part of my work. And therefore, please don't hesitate. Yeah, what else shall I say in the beginning? I think that's it. I'm chemist by education, but not working as chemist as a researcher for a long time. So today I'm not trying to teach you any chemistry, although I will use chemistry examples, of course. But it's mostly how to show you how the database works, and I will use quite simple examples. I will try to cover all areas of chemistry. I don't know which areas you represent, but what I want to stress is that Reaxys has developed a lot since the last time you had a chance to see it, and I hope many of you had a chance to see it and work with it until 2020 when it was available. I will show you how much it developed, and you also have access to all modules. This is called Reaxys Academic Edition. This is only for academia. You have access to all the modules of Reaxys. Okay, so let's go. I will first show a couple of slides, and then we go online and we practice. You can practice with me. And what I also want to stress, and I will say it once again at the end, this is just the introductory training. I will try to show different functionalities. I'll try to show you content so that you get an idea of what is in a database, how does it work. But if you want, and I would really encourage it strongly, if you want to have more in-depth training, maybe focus on a specific area, specific use cases, let me know, and we can organize additional sessions. I would actually love to organize additional sessions in each institution that has Reaxys and work with you and try to work with your examples and see how this works for you. So that's just the first meeting. We are just getting the first ideas, and then we try to get more details in the next meetings, hopefully. And I also hope that I will come in person to your institutions and do it on site. I love to be in Slovakia, so I would come with pleasure. So I think I'll switch off my camera now. We don't need my face on the screen, and we need to focus on the presentation. So let's go on, and then let's see how Reaxys developed. And since the time it started, of course, it's adding new features and new content. And of course, it starts with Ballstein and Gmelin long time ago. And then there was Reaxys Crossfire Ballstein, and Reaxys launched in 2009. I don't want to bore you with all these details. What is really important here is that we started the biochemistry section in 2000. Actually, it was in 2015, 2014, but 2017, we have new Reaxys medicinal chemistry module added. It was called RMC, which is the biomedical part or biochemistry part of Reaxys. And then we added, in 2020, we added Reaxys commercial substances. You haven't had a chance to, I think, to see it. We have a database of almost 500 suppliers so that you can check availability, commercial availability of chemicals and substances from many suppliers from around the world. 2021, we have added a lot of patents. Patents was actually our weak area, I must say, and we knew that. So in 2021, we started a huge patent expansion project. And we have now crossed 14 million patents. And just to let you know, when you were having access in 2020, before 2020, there were only 2 million patents. So from 2 million to 40 million patents now, and growing. Now we have, and I will come back to this. We also have added in 2021 predictive retrosynthesis module. This is artificial intelligence-based synthetic prediction. This is based on the work of Professor Mark Waller, and together with him and his company, we have created this module. You have access to it as well. I will show you. And RMC, Reaxys Medicinal Chemistry in 2022, last year. Actually, this is 2 years ago. It's changed from RMC to Reaxys Targets and Bioactivities. We think this is a better name, and also it got some new features. And as I said, all of it now is included in your subscription in Slovakia, in participating institutions, and this is called Reaxys Academic Edition. And you have access to all the modules, and if there will be any other new modules, you will also have automatically access to it, because you have Reaxys Academic Edition. The core philosophy of Reaxys stayed as it was. That means Reaxys tries to answer your question on the spot, all right? This is different to other databases, and even comparing to the other chemistry database that you also have access to, SciFinder. Because Reaxys has a lot of data which is extracted. SciFinder also extracts a lot of data, but not so much as Reaxys. You will see how much data and information is available, extracted. So in other databases, in most cases, what you will do after your search, you will find that the database is offering you the list of articles, bibliography. Of course, Reaxys is also doing this, but in the meantime, wherever possible, it will also try to give you access, immediate access to data, to structures, reactions, conditions, reaction conditions, physicochemical properties, spectra information, basically anything that you might find useful. You will see that. The interface, of course, we will see. What we know from statistics is that mostly users use quick search. This is this starting screen where you can do the text search or search by structure, but not many people know about Query Builder. I will tell you in the second part of today's training about Query Builder, how to construct more advanced queries. And this is really nice and simple graphical interface. Reaxys it has also built artificial intelligence that tries to understand your question when you ask the text query. It will try to understand it or to translate it to a computer, a query, and then run it. And then depending on your question, it will give you different responses. We will practice this. So you will see if you ask the physicochemical property like solubility, density, viscosity, it will show you the property of the compound. If you would ask a preparation of, synthesis of, it will show you reactions. If you ask nitrification of or esterification of something, it will ask you, also show reactions. But if you ask about pharmacokinetics of a substance, it will show you bioactivity, for example. So it will try to understand your question. We will do this. I mentioned data which is extracted. There is a lot of extracted data. So when you look at substance record, you will get a structure of the substance. You will get all the information about it, and then you get identification data. You get dry glycinase, Lipinski rules, Weber rules. This is, by the way, the only place where the data is calculated. This is calculated based on latest scientific methodology. All the rest is experimentally proven data. So it means it's data which is extracted from articles and patents, which, by assumption, this is something that was confirmed experimentally, right? We don't, we don't try to check it here because we assume this is peer-reviewed literature. Therefore, by assumption, this data is correct. Of course, we know very well that, unfortunately, in many cases, data is not correct. But this is up to you to judge, right? I mean, we are not trying to judge here. Of course, if our indexers find something which is obviously doesn't make sense, then they try to correct it. But usually we don't we don't intervene. We don't try to correct data. We assume it's correct. So basically what we are trying to do is we try to give you all the data very quickly without the need to search for it, to scroll through articles. This is the same as if you found it in the article after, you know, half an hour of reading. The only difference is you find it fast, and then you can judge if this makes sense or not. You can go to the lab, you can try to repeat the experiment, and then you judge it, right? So you see there is a lot of bioactivity data, for example, in vitro, in vivo, metabolism, pharmacokinetic, toxicities, physicochemical properties, a lot of physicochemical properties, much more than in any other database, including the mechanical properties, liquid-liquid systems, enthalpies, chromatographic data, crystallography, electrical, well, basically anything we can find in the article will be extracted. As you see, it will be extracted to a specific field, right? If we find a crystal system, then it will be put into the crystal system. If we find solubility data, then it will be put into the solubility field. I mentioned this on purpose because these fields we will be using in a second part of the training when we will search in the query builder. So we will be able to construct queries from these fields and to build our queries very, very advanced, intelligent way. Then we have spectra information, of course. We don't have spectrograms because we believe in data. So we provide data more than pictures, than spectrograms. You can find spectrograms in many other databases, including many free spectrography databases. So we don't try to create another spectroscopic database. But there is a lot of data information. Other data, quite interesting, a lot of environmental data. I'm not sure if environmental research is important. Environmental chemistry here, you have concentration in environment, in soil, transport distribution, biodegradation data, abiotic degradation, lots of information. Also, you get use of the substance, how the substance is used. This is mostly from patents. And you will also see we get information about isolation from natural source. If you work with any extracts from natural sources, these are mostly plants, but it can be tissues, it can be minerals, soils, basically anything that comes from nature, including products of fermentation, you will see under isolation from natural source. We will do this in a second. So Reaxys, yeah, it's now really a database consisting of many databases, I could say. It grew a lot, and of course, it's a substance database, more than 275 million substances. These are substances from Reaxys. We also have included PubChem data. We also have our commercial suppliers, and we have the patent database. So there is a lot of substances. Then there is a property database. Property, of course, and as I mentioned, there is no other database that has so many properties, and these are distributed over almost more than 500 fields in 130 subject areas. So that's a lot of information, and that's included in Reaxys. Yes?
Sorry, we have a question.
Sure. I see that. Many journals, shift experimental data to supporting. Yes, of course. Oh, hi, Martin. Of course, there is a lot of information, and you will also see when you will find the information, it also will show you the location, and then it will say supporting information, or if it will be a patent, you will see this is saying patent page 135, right? So we also try to give you the location of the information so that you can go to the original source and you can find it quickly. And of course, as you will know, hopefully Reaxys, as any other bibliographic, or actually I call it factographic, not bibliographic database, any bibliographic database does not contain full text. So you will need to go to full text to see all the details, but because you have via CVTI, you have access to many other resources, including full text databases, you will see you will have access to many different full text, and access to patents, for example, is just via patent office, which is usually openly available. Thanks for the question. Yes, of course, we extract from every part of the source. including patents as well. Well, we come back to patents in a second. Anyway, so we have chemical reaction database with all the conditions of the reaction and also experimental procedures, which are extracted as well. And we have bibliographic database. I hear many people saying that if they want to do the literature review, they go to other databases because Reaxys is a reaction database. No, Reaxys is not a reaction database. It's now full bibliographic database. We have 18,000 journals, which is much more in SciFinder, for example. And we also have patent database here on the right, the blue square on the right, patent database, 105 patent offices, which is again more than SciFinder. 170 patent classes, 40 million patents. So we'll also see there is a lot of patent information as well. So you can do the full bibliographic review and also patent review. I'm going to the left part of my chart, bioactivity database. So you have access to Reaxys targets and bioactivities, which is the biggest known to us, the bioactivity database with all data extracted again, and more than 45 million experimental bioactivity data points and the pharmaceutical target database. I think it's now approaching 40,000 biological targets, mostly proteins, including species information, including all detailed information, you will see. I already mentioned patent databases, and also you have access to predictive retrosynthesis, artificial intelligence-based module. I will come to this, which is then included in Reaxys Academic Edition. So I will not repeat what I just said. I just want to mention two more things, and then we go online. First of all, Reaxys is used very well for research, but it's also used for teaching and learning. So many people think that it's only for research. I see Reaxys like in Poland, in Hungary. It's really in Czech Republic. It's really used for teaching as well, for classes. And it's actually, when I talk to students, they prefer Reaxys over other databases because they think it's actually more user-friendly and it's easier to find information. So I see, and I also encourage you to use it for teaching and give projects to students that they have to, for example, look for a certain type of reaction property or substance or whatever other information and bring it back to the lab, for example. We skip this. Patents I already mentioned. We have lots of patents, and you will find a lot of information, including patent assignee. So you can see, you can search for a patent. So you see, like in this search, it's searching for semiconductors. It doesn't have to be, and that's, I think it's a naphthalene-based semiconductors. So you have all this information, including all the patent information, including claims, and claims are always translated to English. So if it's a Chinese, Korean patent, Japanese patent, doesn't matter. Claim will be always translated to English. So you can quickly see if this patent is really important to you. And you can also filter on the left side, of course, by publication, yes, by all the other data, but also by patent assignees. So who is holding this patent? I also want to say two words about Reaxys Predictive Retrosynthesis. This is the module that it's added in as a part of retrosynthesis here on the top. So how this shows up is that you see additional option when you try to do the retrosynthesis. You see additional option to select not only retrosynthesis based on published data, but also on predictions made by artificial intelligence. And then on top, when you go into your projects, you will see that you have these blue squares, which means these are the published literature-based retrosynthetic plans, and you will see the green ones, which are predicted. We will show this in a live environment. Easy access to data, and talking about bioactivities, we also will do it. You see there is a lot of data. So it's not just the article. When you go to the substance, you see the bioactivity in vitro, in vivo, metabolism, pharmacokinetics, toxicities, and so on. And you will see a lot of data which is extracted, which is not only the parameter measured, like GI50, IC50, whatever it is, the value of it, but we also translate it to a common measure called px, which is like unified measure of bioactivity, which is by definition negative logarithm, but it's based on scientific, again, developments, because each parameter will be translated to px in a different way. And this allows us to compare different bioactivities regardless of the parameter it was measured. And this is also color coded, so from like nice red and yellows for high activity through greens down to blue, which is low activity. You can quickly, if you're working on bioactivities, this is a fantastic tool to see that. And you also see the data on action on target, inhibitor, blocker, activator, whatever it is, target, cell lines, effects, it's evolving, and so on. So a lot of information. We will go through this. And you can also visualize the bioactivities. If you have many compounds and many pharmacological targets, you will see, I'll show you. This is a bioactivity visualization, where you can see your compounds on the left and your bioactivities here on the top, and then you see color coding as well, and you see where the high activity occurs and where not. And you can also do the selectivity study. You can see for which pharmacological targets the activity is high and where is low. So you can be selective in terms of bioactivity. Okay. What I also wanted to say, of course, you have, as I said, you can contact me on anytime you want your support, but we also have Reaxys Academic Edition help. I mean, you can look at Reaxys channel on YouTube. If you just search for Reaxys, you will find the Reaxys channel where we have lots of nice videos, how to do different types of searches. And we also have Reaxys Academic, we also have Reaxys Academy as well. I can give you the link to this, which is a site with lots of learning materials as well. By the way, we also have the mobile phone application, which is called Reaction Flash. This is just the tool for organic reactions, and you have all the named reactions here. This is free to use. You can just download Reaction Flash to your phone and use it for free. This is created by Reaxys, but as an additional resource, students, I know, use it a lot. So this is just a modern way to do this. So, okay, I think that's enough for PowerPoint. Let's go to the live demo. So I hope you all have access to Reaxys if you are at your institution, at your university or Academy of Sciences. If you are, just put in reaxys.com, it should work, right? You should see this screen. If you don't see this screen, let me know. We will resolve, or Lucia or Ladislav from Albertina know, and we will try to find out and let's see what's happening. But usually you should see this screen. Now, you can work as anonymous user. You don't need to log in, but if you will not log in, your session will last 30 minutes. You will not be able to export any data. You will not be able to save anything. So what I usually suggest, please log in. You see I am logged in here, and if you don't, you will see a register button. If you don't have an account, register is just the name and email address. It's very simple. You don't need anything else, and that's free to use. And by the way, this is the same account for all Elsevier databases. So it's the same for ScienceDirect, Scopus, Reaxys, for example, Saival. So if you have already one in ScienceDirect or Scopus, you can use it here. Log in with these credentials. If you don't have one, set up your account in any of these databases, and you can use them in all Elsevier databases, including Reaxys. So you see I'm logged in, and I asked my computer to remember it, so I don't need to do anything. It opens automatically and logs me in automatically. So now let's go to searching. So how can we search? I know from statistics that 95% of searches are done using structure editor. Of course, I know many organic chemists love it, but let's I really want to show you all other ways of searching. We'll come to structure editor in a second. First of all, you have this search Reaxys, this text search. Just to show you, this is the field, and because we have 18,000 journals, and now I think Scopus has now 28 or 29,000, so it's a big part of Scopus actually. You can search for anything. including the medical concepts, right? And searching for heart attack. And you see when I'm typing, Reaxys immediately gives me the prompt, which is based on a dictionary. So it works with the dictionary called Reaxys 3. And if I will select it, it puts it in a quotation mark, and it makes sure that I'm searching also for synonyms. In this case, I'm not expecting any structures, right? I'm only expecting documents where titles, abstracts, and keywords contain heart attack. You will see how transparent this algorithm is. You will always see how Reaxys thinks. So almost 500,000 documents, and this is a typical bibliographic view, right? And by the way, you see I asked for heart attack, and I'm seeing myocardial infarction, I see heart infarction, and so on. This is proving that I'm searching for synonyms. Here I can use the filters like publication year, like document type. If I just only wanted articles, patents, review articles, conference papers, you can always click on view more, by the way, in the filter, and to see the full content of the filter, right? It's very easy. So if I'm looking for chapters or conference or book reviews or editorial articles, whatever, then you can just mark, or you look for patents, click limit 2, and you're done. So very simple. So you will see the filters will be different for text view, for article view. When we will be in a substance view, it will be different. A reaction view will be, again, different, right? So here I can also go for journal title, for the authors, for example, and so on. So this is related to my text search. So here I can find not just the information I want, but also get an idea of who is the author, which institutions are active in this subject. I mean, this is like a huge subject. My search, of course, was too broad. That's why now it's taking some time to even look for the filters. But that's quite important. But if you look for keywords, that's also nice. Maybe let's use another example, less medicine related. Corrosion, for example, inhibitor, right? I'm looking for corrosion inhibitors, which is more chemistry. It's like more chemical technology subject. But this is sort of, again, more text search than anything related to a structure. Why is this so long? It should be quick. See, that's crazy. This is crazy.
Something is wrong.
Let me see if I can do this.
Yeah, maybe another browser.
I hope it will not kick me off, because then it's often saying I am logged in too many times. Okay. This one in Edge. In Edge is working. So okay. So my Chrome is getting crazy, it seems. Okay, you see, I have the register button. So what I will do is I will sign in. I'm not using usually Edge, that's why. See if this will work. So you should see normally your accounts, and this is the insert manage remote in this case. Oh, come on. This is, yeah, I was afraid of this. Too many active logins. And then I will have to wait 5-10 minutes. So now we have a problem. That's beautiful. Too many active logins. Okay. Hopefully it works. Okay, so what I will do is I will work for a while without signing in. Hopefully this will let me in. Good. And then I will sign in to show you the rest. Okay, so you see I was searching for very generic subjects, but of course you can search for a substance. And of course you can search for a UPAC name. And the more you type, you see, the more exact this help is. So there is this autocorrect function, and this will help you. This will help you to find more and more exact, exact information, and the more you type, you will see that you can get more specific. And in this case, if I will do the search now, you see my search is different because now I'm getting substances, I'm getting documents, and I'm also getting commercial substances. So you see this is different. You can go to the document view. We already know how it looks like. We can go to the commercial substances directly from here. And this is what I told you. We have a database of 500 suppliers. So you see the product, the purity, packaging size, availability, and you see different suppliers. You can go to supplier, for example, geolocation. So you can select suppliers from different countries. You can also do all the other filters, and you see the filter is already different from the one that we have seen in text search. You see you have the link to the supplier page, you have the link to the product page. If available, you will also see SDS, safety data sheets as well. The links are there, so there is a lot of information. Let's do the search once again, and of course, the substance record, right? This is where you would usually go and try to see the substance and see the information. Actually, for this substance, we don't see a lot of information. It will depend on the information which is available, of course, right? So if there is not much, you will see not much. If we will search for something more, I'm using coumarin on purpose. I know it's boring and it's obvious and it's simple, but it's very well researched. So just the purpose to show you how much data is there. And you see here, we have much more information, right? So on top of the structure, we have a link back to commercial substances, this shopping cart. So you can go to commercial suppliers. A link to the synthesis plan. Of course, we will not synthesize it, but here you see create retrosynthesis plans. And here what you will see is that you have, now I don't see predicted, right? Because I'm not logged in. And I'm working from the IP range, which is not attached to any university. But you will see that when I will log in, when I will sign in a second, you will see the predicted plans and published plans. So published is what you usually see, but you also have access to predicted ones. We will do them in a second. Now, all this data, starting from identification, right, data, so lots of information. Drug likeness, I told you this is the only place where the data is calculated. Bioactivity data, lots of data again and again. This will be data, as I said. So you see there is all this information which is here, and this is extracted, including all different information type like cell lines, dosing effects, and so on. So in biochemistry, it will give you a lot of data. Physical-chemical properties, spectra information, and other data, including use of the substance and isolation from a natural source. And you can see like fruits, stems, all different ways of extracting from nature. So all this information is here. And then on the right side, we will see also the preparations where our substance is a product of the reaction, all the reactions with our substance in enroll, pharmacological targets related to the substance. Again, this is not a biology database, right? This is a chemistry database, but you see basic information about this pharmacological target, and you see as much information as possible, including links to UniProt, PDB databases, and so on, so that you can also look at this. But in principle, that's not a biology database. So that's why we provide links to typical databases like UniProt or PDB, so that you can check exactly what you should see. And yeah, and also there are documents related to the substance. So you see there is a lot of information in the substance record here. And you also have more options, like view options. You can copy back to query, copy smiles if you want to copy to another structure editor, for example. In the same way, we will be able to copy to our structure editor. So you see, I was searching for substance. Now, it can be even more complex because I can search here for anything. I can search for an author, right? Although it will be more exact to search in query builder, I will show you later. But you see that in this case, Reaxys understood I'm searching for an author.
One question to the substances and
Sure.
and to suppliers. There was a price in US dollars. Is it possible to see it in euro, or it's always seeing only or showing in US dollars?
I think it's unified to dollars, and these suppliers are from different countries. So I think to make it easy, this is in dollars. But you can always go to a supplier page. You can go to results. Okay. Let me switch to any substance. You can always go to a supplier page and you can see the original. And I'm not sure, like China, will it be in dollars or will it be in... there's something strange, most probably here. Okay, let's skip China. Okay, let's maybe the supplier geolocation. Let's see Austria, Belgium, and Japan, whatever. I just want to see if there will be in Japan, for example. The Chinese one didn't want to work. That's LabChem. Yeah, so here basically you are getting, okay, that's a Japan yen actually. But I think you are getting, what you are getting in Reaxys is the price, the lowest price from this supplier, right? So it depends on price on demand in this case actually. But usually you will see the lowest price from the lowest supplier. So it depends. I think the best way is to go to the supplier page. Okay, but let's go back to the searching, because here in this quick search, you can really do a lot of things, because it doesn't have to be just the substance. It can be the property, for example, right? So if I will go solubility of, and then try to either say, I can say the drug name, right? I can say the UPAC name, whichever. You will see I have a substances with a structure like this, which is diazepam, and property solubility. So you see the query, how it's built. I also have the documents where solubility and diazepam is mentioned, so you can take different looks. But if I take the substance look, you will see that on top of the record of the substance, I'm also getting something which is called hit data. Hit data means the answer to my question. And then I get solubility. So without drawing anything, I'm getting 59 hits of solubility of the substance, right? And this was quite easy. So very quick way, don't have to draw anything, just say solubility of. Doesn't have to be organic substance. It can be even electrochemistry, right? If I want dissociation exponent, for example, pKa of phenylboronic acid. Oops, there is a mistake. Phenylboronic acid. That's the one I wanted. Again, substance. You see now it's getting really a bit crazy. The Reaxys is getting stupid and tries to give me the target pKa, which doesn't make sense, but property pKa is what I wanted. So I see phenylboronic acid and I see dissociation exponent, right? So works. It sometimes will not work. If it will not work, then we go to query builder, of course, and I will show you in a second. But I will show you still a couple of examples that it works. Like magnetic moment, for example, gadolinium or gadolinium. Let's see. So magnetic moment, you see, and now it will be just a pure element. It doesn't have to be a substance. So I have gadolinium and I see magnetic data as well, magnetic moment. So I'm just showing this to you because I really want to prove that Reaxys is not pure organic reaction database. It's all chemistry, or actually I'm saying all life science database. Vickers hardness, and so on. It can be spectra, right? For example, 19F NMR of fluoxetine. And you see, Reaxys is helping me all the time. So it's trying to understand my question on the go. I have a substance property, 19F NMR, which makes sense. So I will see fluoxetine and I will see NMR spectroscopy data, right? And this will tell me, you see, it tells me the location, for example. So it tells me it's in supporting information. And then I just go to full text and I try to find it. So we don't have spectra, we don't have spectrograms, as I said, but you see all this information and you can see all the literature in the subject quickly. And you see, for example, if there is a solvent given or it's a frequency given, whatever information is possible will be extracted. I can also go and ask for a reaction. We just type preparation of or synthesis of vitamin D3, why not? Let's try this one. So you see, I have now a different response. So I see reactions. I can see the reaction query. So you see Reaxys drew the reaction query for me, the results. Of course, I also have documents about it as usual, but I see reactions and I see the reactions, I see the conditions, and wherever possible, I will see experimental procedures which are extracted as well, right? So everything is here and it's available. And of course, if you want, you can also do the literature review, because I also see the documents where preparation in vitamin D3 are mentioned. So depending on what you want. So you see, this is a very useful tool, and try different things. Put in the patent number if you want. Put in whatever you try to do. In the worst case, you will just get the text, the results only, right? Recently, we were also searching for reduction of vibration in metro, and we also found a lot of articles. But of course, as a chemist, most probably you will go do either a type of search of a substance or a property, and you will also go to the structure search, probably, I think. So what we can do here is, first of all, we have two structure editors, Marvin.js or ChemDraw.js. You can, if you are mostly used to ChemDraw, for example, you can use it. You can use it here if you know if you prefer the interface. So you can choose it. You can, even if you are signed in, which I cannot do now, you can go to your profile and you can set your preferred structure editor so that it will open. If you like ChemDraw, then it will open ChemDraw automatically. What you can also do, I prefer Marvin, so maybe we stay with Marvin.js for a while. You can use it in a different ways, and of course there are different patterns. I will go through them quickly. But what you can also do, you don't need to draw everything. You can just go insert structure from name. And in this case, I don't advise to use UPAC names, because this function does not have any autocorrect function like the quick search, for example, right? So whatever you type. And if you make a mistake in a comma or a dash, then of course it will not accept it. But for simple names, for drug names, for example, it works perfectly, right? So for drug names, for simple names, for commercial names, this will be a great way to do this. And then you can start drawing, or you can say, okay, that's my base. And then let's try to see if I can modify it somehow. You can go for more options, and you can, for example, search for a substructure. In this case, you will search for any possible substitution. Or you can be more specific and use, for example, generic groups here on this orange R on the right, and say, I want any, for example, any cycloalkyl or any aryl on this position, for example, right? So depending on how you want to do the substructure, in this case, I leave it as strong, so that this is the only way I want this structure to be substituted. You can use different bonds, of course. Reaxys understands the stereo bonds, down, up, and so on. You can also do like single or double in case you want to search for multiple compounds, any bond, coordination bonds, position variation bond, very interesting bond if you want to check substitution on just on one of many atoms. You would just mark, for example, this 5, and this puts methyl group by default, and then maybe you can say any group here. So basically you are checking all the compounds with just one of those 5 carbon atoms substituted. Depending on your strategy, sometimes, and I know many people are searching just for very, very exact substance, but sometimes it makes sense to search for a substructure so that we can search for a group of compounds in one search. We can do it like this. We can also search for chains. We can search for, we can also do the repeating groups. Here we have repeating unit, and if we mark, for example, this carbon atom, we can say exactly how many, or we can do the ranges as well. So that in this case, I will search compounds with chain from 1 to 5 carbon atoms on this position. So there are different ways of being of searching and being really creative with it. I was recently asked to search for cyclopentane and cyclohexane based compounds and how to do it in one search. And that's also very easy because we just thought that we could repeat one carbon atom in a ring and say 1 or 2 atoms, which means in this search, whatever is the rest of the compound, right? I don't know. Let's put a I don't know, amine group, whatever. So we are searching for cycloheptane and cyclopentane and cyclohexane based compounds. What's more, we can also include compounds that are aromatic as well if we would maybe change the bond to single or double. Oops, sorry, this is not here. So as creative as you can be, in this case, we would search for 5 and 6 membered rings, and we also would search for single bonds, but also for double bonds in one search. So there are very, very creative, some very, very creative ways of searching for different compounds depending on what you want. Of course, we also have a periodic table, which is nothing special. What is nice, and many people also don't notice, is that you can also create atom lists. So if you create an atom list, and I say carbon, nitrogen, or oxygen, that means in one search, I will do 3 searches, basically, right? So I will search for 3 different compounds in one search. So there are many, many different ways. If you want more, we can go through all different examples. Maybe one more is abbreviated groups as well. Just start typing and attach the abbreviated group. And if you right-click on it, you can expand it to make it nice. And right-click and contract it as well. Right? It can be this, it can be COH, it can be anything. If you want to find out these groups, then if you go to help, which is, by the way, quite useful as well, and you go to Reaxys Support Center, you'll open a new tab. Just search for abbreviated, abbreviated. Okay. So how do I add an abbreviated group templates? And here is the list of available abbreviated groups. That's basically PDF with all the groups, right? So if I know some students cannot find their groups of interest, here you will see all groups that are potential. If you work with some, usually you work with some small group of different ligands of substituents, this can be quite useful. And you can save this PDF basically and use. from other nice options, I don't know if we should go that deep, but you also have, of course, reactions, it's obvious, right? I mean, you have a plus or an arrow, and that's quite obvious. But you also can use this tool to, for example, map atoms. And maybe you can map atoms in many cases. One case could be if you had, for example, two protective groups and you wanted to detach one of them, then you would need to map both, like in VOC group, you would need to map both nitrogens. You can also do it. It's nice if you do the, transformation of, for example, of functional group. Let me just copy paste. By the way, you can copy paste from other standalone editors as well, right? If you use ChemDraw or any other, just copy paste and you can copy paste, or you can open saved files as well. You can open saved files from different formats as well. So that's quite easy. In this case, what I want to do is I want to do the transformation of a functional, no, that's not what I want. Okay, I want to just make a very simple transformation of carboxylic group into trifluoromethyl. Now I have as drawn, right? So nothing special. If I will do this, I'm expecting one reaction. Okay, there are actually two reactions. There are also some similar reactions, but that's not what I'm interested in, but you can also look at it. And that's my transformation. Now I go back to quick search, click on structure editor. And now if I will use substructure search, it means I'm allowing any substitution on any atom. If I will run this search, then I'm expecting many reactions. But the problem that we can anticipate is that you will see that, for example, my trifluoromethyl group is already present on my starting material. So it's not a transformation. Also, you see my carboxyl group is substituted, and so on and so on. My results are somewhere in this set, but I cannot find it very quickly. And going through 1,600 reaction doesn't make sense. So let's go back to quick search. Go here, and then what we can do is here on the bottom is manual atom mapping, but we can also use the same tool that we do for reaction drawing, and we just start with this carbon and mark it and put it to this carbon, right? And this is manual atom mapping, and we have mapped one atom. We can do the same with another one, but in this case, it doesn't make sense. But if we had two VOC groups, we could mark both nitrogens and show which one is detached, which one is not detached. In this case, we just mark this carbon atom. It's still a substructure search, so very nice. And we run this search. And in this case, we are expecting less. Okay, we have 30 substances. And you see, this is exactly what we wanted. All the other groups like chlorines here, metal here are the same. This is elegant as well and nice. So you get the whole idea of the whole group of substances. And I think this is quite, manual atom mapping is quite nice. There is another nice function here, which is a smart groups. I don't know if you use it. That's also helpful in case of doing groups of substituents that you want to add to your reaction. And maybe let's try to do this. I hope I can fit in, because in Chrome this is much bigger, but here it is just giving me a little space, but okay. So what do we have here? Let me remember this. I think this was like this. oxygen, I think I'm too close to the edge, but I want to keep the right side. I will need it to draw my groups. So that's my scaffolding, and now I'm using this tool, which is called Smart Groups, and I'm saying this is R1, and you see this is automatically numbering, and if I do R2, I can click on this anytime. I can switch off auto numbering if I want 2, 2, 2, and 2, and so on. If I want the same, the substituent from the same group of substituents, but in this case, I still want to go on because I want to, to here, right? And I want both of those to be from the same group. So I will change it to 3. So I have R1, R2, R3. These are my 3 substituents. And then I left the space on the right side on purpose just to be able to draw them. Just a couple of examples. My screen is too small. I see here, but let's try to do this and very quickly, not to lose too much time on this. The second one will be, it can be any halogen. It could be oxygen, and the R3 could be hydrogen. It could be hydrogen, okay. Any alkyl or any aryl. You see, so this is quite generic, but you can do it in your way. I was drawing this in lines so that I can now take the same tool that I was drawing these R's and just mark them like this. You see automatically marked R1, R2, R3. So you can even use it for one. If you have just one search where you want to test different substituents in one search, you can just do R1, 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 and that will be fine. In this case, it's more complex because I have 3 groups of substituents like this. The last step I would need to do is I would need to use this attachment tool. So for more complex groups, tell Reaxys via which atoms it should attach, right? I mean, for this, we don't need to do it. And basically, that's my search. I leave it as drawn, so I don't allow any other substitutions than this. Make sure that this is as drawn. Transfer to query. I forgot one thing. I have 18 substances. Sorry, I have to go back because I just reminded myself. Edit. That's this here. We have we want a longer chains here from 1 to 5 atoms. So I will use the repeat unit. 1 to 5 atoms. So this will give me more options here to extend this chain. Again, transfer to query. It should give me more results, right? Yeah, that's exactly what I wanted. 1000 results. And you will see gefitinib on top of this. And this was actually the search for pharma company for gefitinib and substances which were according to the same search strategy. So you see how quickly we get 1000 compounds, and now you can go through different filters. In this case, again, filters are different. For example, substance classes, and click on view more, because some filters are the lists, but some filters have the form of a tree, like this one. So for example, I can go and say for my 1000 compounds, functional group classification, and I want compounds, if I want the amines, I want primary amines, for example, you can see how easy it was, right? So with oxygen, I don't know, hydroxyl, or with halogen, I want any halogen, I want only chlorine, and I want alkyl chlorides and aryl chlorides, and limit 2, and from 1000, I'm down to 175, right? So you see, this is quite easy to do. I can also go through other different filters, and you know, including document types. So if I only want the data, the compounds that are used, or they are mentioned in patents, and so on and so on. So all this information is here. From here, I can also switch to documents which describe those. I can switch to reactions. So you can switch between the display substances, reactions, documents, and targets as well. And I switched because I wanted to show you how different the filters are. In this case, for example, reagent, catalyst, solvent, which is obvious, right? And if I click on view more, it's just a list, right? And I see which are the most popular solvents or catalysts. But what is really nice here is solvent classes and catalyst classes. If I go to catalyst classes, view more, then again, I can go via active center. So if I am interested for these reactions for palladium-based catalysts, then I see which ones exactly were used. I can just select those that I want, or I can select with one click the whole group. So I want palladium and, for example, nickel-based catalysts only. And then quickly you go to 27 reactions. So that's also quick, a nice tool. You see on the left, the history of my searches is building, by the way. So I can quickly go back to the previous stage. I don't have to go to do the back in the browser. I can go back to the previous stage because I wanted to show you also the solvent classes. And you see solvent classes, Reaxys understands which are, for example, green. So you could go like this one by one, or you can say, I want all green solvents, or I want all protic or aprotic or yellow solvents, right? So very or low boiling solvents. And you can immediately select your reactions down to a specific type of a solvent. So Reaxys has nice filters, and in the filters, click on view more because it gives you, usually, in many cases, it gives you a much better possibility to select your data. So that is the structure editor. I don't think we need to spend more time on this because you will know how to navigate through this, most probably. I mean, this search was really nice. And by the way, if you want to save it, you just click on save. You can save it in different formats, but if you just select the default MRV, the Maxon Marvin format, what it will do is it will download a small file. It will download a small file. You can close it, and you can save this file. I hope it downloaded somewhere. Downloads. Yeah, you see, this is this Marvin untitled and so on. You can change the name of it as well if you want. So then, if you can save it to your colleague, and then once you have it, you just open it, choose file, and you can bring it back. Downloads, Marvin, open, and that's here, right? So very, very easy. So I think that's enough on a structure editor. Unless you have any questions, please shout. We will still use it, but I really want to take you to Query Builder. Maybe okay. One more on. You can also check here the bioactivity. We can do this later in advanced mode, but you can also try to do it here. Pharmacokinetics. So what I'm doing. I think there is a mistake. Of course, there is a mistake in pharmacokinetics. So you see now I'm getting a different view. I'm getting targets, but I'm getting substances as well. And normally I'm searching just for one substance, imatinib, right? So I should get one, but I get different versions of it. And you see bioactivity, all. This is the view I was showing to you, but I also have bioactivity heat data. Always look for heat data. In case of bioactivity, it will be here. Normally, the heat data is under the substance record, but in this case, I don't know why it's here. And you see, this is pharmacokinetic. I was searching for pharmacokinetic of this substance. That's why I'm getting the substance record with pharmacokinetic. Select it out of all the data. If I want to go to all the bioactivity data, is here. So here it is. And what I can do is, I was already talking about this bioactivity visualization. And normally I have just one substance, right? And okay, here I have just the gray areas, which means I have only the px was not determined. So this is only qualitative data. If there was a quantitative data, I would see these different colors. And I can click on every of these fields and I can see the information, right? So there is no px was not determined for some reason, but I see the data which is here as well. So you can either click on any of those squares, usually they are colored, or you can export. Of course, the login is requested, I know, but I cannot. You can export data and you need to be logged in, of course. I would really prefer to do it in. Okay, I'm logged in. Great. Let's see if this will work. Inhibitors of COX-2. Okay. Very nice. So you see the substances where target is COX-2 and action on target is inhibitor. Makes sense. Now it's working. Great. I think I can close the. Okay, so you see I have 8,000 substances, and this is not giving me the idea how this works. So then I can go to bioactivity visualization. And in this case, you will see colors. You see that I have different versions of COX-2 of this target. And by the way, you see by this, the size of this circle that here I have a lot of data, and you can also see it on a navigator, on a miniature, that you have a lot of data. There is also some data here, but you can easily click on the column, for example, or many columns if you want more of them. Which one has some data as well? Let's see, for example, this one, right? I see there is also some data. So I can select those two columns. 3 dots in Reaxys means there is more data here. So I click on 3 dots and go limit to selected columns. So you see, this is not a typical bibliographic search. I'm already playing with my data. What I can also do, click on 3 dots. Maybe let's close the navigator. I can click on 3 dots and go sort by activity. So I'm getting my target and most active compounds. Compounds that are most active on my target, right? This is 12.8. This is negative logarithm like pH, so 14 is the max value, right? So 12.8 quite high for melexicam, for example. And I can click on this and check all the details here as well. Always on the right side in Reaxys, whatever you're looking at, we will have the source of the information, right? You remember this. And because now I am logged in, I can now show you the export. Preferred is this Excel and all results, or you can select it, but the maximum is 5,000. So I will need to maybe sort the data or limit the data. And you can also choose specific data, and you can add data points that you want. So you can specify what you want to export, right? I want concomitants, for example, or I want tabloids, and so on and so on. So depending on what you want, and click on export, and it will be done. Very nice. So this is searching in a quick search, and you can see text searches and you can see this, but where really you have a lot of different new possibilities is in the query builder. Of course, if you have any questions, please shout. You're very silent. I hope everything is clear. But again, this is just to show you roughly what Reaxys is now doing and give you ideas where to look for what. And if you want more, tell me, contact me. We can organize for your lab, for your departments, for you, whatever you need. Just tell me. It doesn't have to be full hour. It can be 20 minutes, whatever. I am at your disposal. So query builder, how do we use this? You remember I was talking about these 500 fields. Where are these fields? They are here on the right side. Topics and keywords, anything related to substance, anything related to reaction, anything related to the text search. Here we have more exact identification, chemical name, and so on. Physical properties, melting, boiling, sublimation, chromatographic data, and so on. Spectra information, biochemistry, target name, action on target, substance effect, other data, isolation from natural source, use, and so on. Reaction data. You see a lot of data here, and bibliography. If you want to make a typical bibliographic search, document type, I'm searching for patents with or some journal title or whatever, code and DOI, it's also possible. How do we use the field? let's take the physical properties. You just click on the field you want to use. You see, and this is now added to my interface. If I click on another one, it's also possible, and there is no limit to how many fields you can use, and automatically they are connected with the logical operator AND. If you click on this AND, you can change it to not, near, and so on. So each field will also have the subfields, right, specific to the field. So if I have a melting point, I'm looking for compounds that are melting between 100 and 110, and boiling, for example, with temperature higher than 300 degrees. You see, so I can use more or less, I can use ranges. So this AND connects these two. And now I'm not giving the structure. And here I have to define what I'm searching for. In this case, I'm searching for substances. So you see, quite easy. And this can be a compound. It can be an elements, whatever. Benzophenone, for example, let's see. And you see key data, melting point and boiling point. So nicely, all the information is there, right? I could add also, I could add some part of a drawing. So I go back to Query Builder, and I can add also a structure. So I can add structure editor as one of the fields. If I click now, you see I have my two fields, and now I have the third field, which is the structure. And I just draw the part of the structure I saw. Like this, and I will do the substructure. Okay, so I just want this to be a part of my structure. So I'm looking for a compound that have this structure as a substructure of this, and that have these properties. And again, click on substances. I don't know if there will be any other in this benzophenone we were looking at. Let's see. So now it's going through the database of all the compounds that have this substructure, and then combining this information with the information on solubility and melting point. Okay, out of 170 something, you see all of them will have benzophenone. Okay, there are more. Great. This one, okay. You see, this one also, it has a closed ring. So this might be something you want or not, but there is this bonds here that we wanted, but additionally, this is in a ring. So maybe this is not exactly what we wanted. I mean, this is correct, for example, but this is already also in a ring. I think we could actually get rid of this. Sorry. By the way, we could get rid of these rings if we didn't want them. We could right-click on a, right-click on the bond properties, topology in chain. And this one also, bond properties, topology in chain. Let's see how this looks now. Just an experiment. I was just thinking, okay, from 35 to 21. Beautiful. Okay, great, works. So you see now we got rid of these closed rings. Very, very beautiful. Okay. So you see, I'm getting compounds with a specific properties, with a specific structure, and I do it in one search. And this is nice and easy, way to do this. It doesn't have to be always a structure. Sometimes we use molecular formula, but it also makes sense. For molecular formula, we can put something specific like C2H5OH, and we mean the ethanol, but what it will do is it will sum up the atoms. So you will see I'm getting all the compounds with this number of atoms. So of course, ethanol is there, but ether is there, and so on, including the isotopes as well, and so on and so on. So what it is doing, it is summing up the number of atoms. So basically, this is the best way to do it. Like I want 3 atoms of carbon, and I can also make a parenthesis 2 to 3 atoms of nitrogen. I want any number of atoms of sulfur. question mark means any number of atoms, right? If I would put here an asterisk, it would mean, and I also want any other atoms that just collect anything else that you want. But at this time, let's just try with these 3 elements. So you see, this is another way of searching. It's not always that we search by structure. Sometimes this makes sense also if you want the number of atoms. For inorganic chemistry, that's the best way to search. I mean, there is drawing this, the structure editor is not a good place to search for inorganic compounds. Inorganic compounds would be the best way to search here. Pure forms of elements, if you look for fullerenes, I mean, drawing a fulleren would be a nightmare, right? C60 is much easier. And you get your fullerenes. And if you like the one and you want to continue drawing, click on 3 dots, copy structure to query, and you have it in your structure editor very quickly. So sometimes there are these smart ways of getting things done, and then you can continue drawing if you want, right? So depending on what's your search. Using this, I can also go and find, for example, combine data with use, for example, right? You remember the use of the substance, and this was somewhere in other. By the way, next tip is you can search for fields. I mean, if you want to find something related to chromatography, start typing Chrome, right? And you see chromatographic data. You want to find something related to optical, type 4 or 5 letters, and you see all the fields related to what you want. If I wanted optical rotatory power, right here, well, maybe we do this in a second. I wanted to find use, and you see how quickly I can find this. So let me see. I want to find, for example, lithium manganese oxides that are used in batteries. Lithium, and I will use for this molecular formula any number of atoms, right? Manganese, any number of atoms. Oxygen, any number of atoms, right? Show fields, use pattern, battery. Now, the next tip, because sometimes it's battery pack, sometimes it's batteries, right? So we have to do the smart search. We, as the researchers, I mean, this is not Google. This is index information. That's why we have to think what kind of results we can receive. So batteries. So what I would do, I would stop with R and would say starts with. If you think there could be any prefixes, then you could also use contains. That means this would be in the middle. But I think starts with, in this case, is good. So I'm looking for lithium manganese oxides that are used in batteries. Let's see, for substances, not bad. So I have lithium manganese oxide, and I see some patents related to using it as a cathode for alkali metal batteries. So again, not only organic chemistry. I can mix structures with properties. I can mix analytical methods, right? I have a compound. I'm analyzing a compound that has 30 atoms of carbon, not like this, like this. So C30 and asterisk, meaning all compounds having 30 atoms of carbon. I can check every step I'm doing just to see if it makes sense. So there is 1 million compounds containing 30 atoms of carbon. Okay. Now, I'm measuring, for example, I'm optical rotatory power. You remember I was searching for this optical rotatory power, show fields, and I'm measuring and I'm getting, I can enter any information I want. In this case, I just make it very simple. I measure something between 80 and 85 degrees. Let me check if this works. Okay, 651 substances, olanoic acid. Let's check optical rotatory power. 81, 80, okay, makes sense. And I see also the literature for this, right? I hear that someone has isolated it from the natural source. Now to isolate it from natural source, so I'm adding the third field. In this case, if I would know from what source, right? But then, yeah, I think I remember it from some previous searches. Okay. So now I'm getting two answers, right? Optical rotatory power, I was already looking at it, and isolated from a natural source, gardenia, right? Seeds of gardenia. If I didn't know what natural source, I wouldn't do it. I would just say here, find any. Find any meaning, show me all results where there is any mention of isolation from natural source. And okay, now we are at 200 substances, right? And organic acid is also, of course, here, but we have more compounds. So you see, this is quite easy, and you can really manipulate this. You can really go in a different way. You can look for compounds also used for something. And just one more tip: topics and keywords. If you don't know the field that you should use, then here are the ones related to substance, reaction, and text searches. They are very useful because they will search in any field. So if I'm looking for example, compounds, argon and palladium containing compounds used in stereoselective catalysis, argon, any number of atoms, palladium, any number of atoms, anything else, asterisk, right? And stereo, like and I'll just use contains because I don't know if it will be stereoselective catalysis or whatever, substance properties and comments. So I'm trying to find compounds which are based on argon and palladium and are used in stereoselective catalysis. And you see I'm getting the compound, and I see catalyst investigation, stereoselective catalysis. So actually I could use this field, catalyst investigation. Yeah, for this search, it would make sense. Sometimes you will see different fields, sometimes 2 or 3 different fields. Catalyst investigation. Okay, nice. By the way, you see these compounds, some of them are like faded out, and this means they are not wrong. They are, you can go and you can do the, you can look at them, and you can look at 3D as well. Click on 3D, calculate 3D, and click on rotation, and you can also rotate them. Sometimes for students, this is nice tip. Going into biochemistry, looking for compounds that have a specific use or a specific properties. I don't know. I'm looking for chromone. Like I'm looking for some compounds that have a specific properties, and I want to find compounds that are, for example, let's take a substructure, right? I mean, I don't have time now. We have 2 minutes, but if you have 5 more minutes. I want just a substructure. In this case, you could be more specific, transfer to query. That's my first field. And I want to, for example, use find compounds in that are, for example, used versus specific target, right? Like COX, no, subconnection on target. I want, for example, inhibitors, and I want the target name, for example, COX2, right? So I'm looking at a group of compounds that have a specific action against, and quercetal, for example, bioactivity data. And you will see that this is inhibitor against COX2, right? So nice search. I can also go and say, show me compounds that have specific action. So let's stay with chromone, and let's use, for example, substance effect. Are there any of those that are researched against Alzheimer? And again, I would use contains because it can be anti-Alzheimer, Alzheimer's, and so on. And I'm getting substances, 992 substances again. Let's take routine, for example. So you see I have in vitro, in vivo, and you see here anti-Alzheimer agent, and this is inhibitor, right? So again, quite useful. So you can combine any field with any field, of course, as the logic goes, and you can try to find different information depending on how you want to do this. You can also go and find, for example, compounds that are having certain properties or certain use of the substance. I can search for I don't know, benzoimidazole derivatives that are used as fungicides. Very simple search, benzoimidazole derivatives. I will just do the substructure again. I don't have time to go for specific structures, and I will get use, or actually I will just use substance properties and comments. Fungicides, so maybe we say starts with, right? And I'm getting the compounds, 70 compounds that are fungicides, hopefully. Yeah, fungicide, you see, it's nice, and it's nice tool. Just again, one more tip. If I wanted, somebody asked me one training, and if I wanted to find also pesticides and biocides, any sites, they said, what is common for them? The common for them is site, right? So they said, let's look for site, but in this case, the word has to end with site, right? So fungicide, pesticide, all sites. And let's see what are the compounds that could be biocide, pesticide, fungicide, and so on. And you see, we also have bioaccumulation data, nice, but use will be more important. Fungicides, only fungicides, bactericide, pesticide, insecticide. Okay, we get it, right? So you see, this tool allows you to be really creative. For reactions, the same, right? You can do the reaction drawing, and you can do, for example, reagent catalyst. So you can draw a reaction and put in the reagent catalyst here. You can do also more generic search on reactions, including, for example, enzymatic reactions. Glucose would be a nice starting material for this. So let's just do, again, very simple thing. And we use now, in this case, we use reaction data and conditions. So I don't know which field to search in, but most probably reagent catalyst, right? But here, and I say enzymatic, but I could also search for enzyme kinetic. So maybe we stop at M. You see my thinking, and I say starts with. So enzymatic and enzyme kinetic will be included. And now I don't search for substances, I search for reactions. So you see how many possibilities it gives. It's really giving us nice ways to search, to explore this. When we build this, we can also save them. We can save the forms. I don't want to go too much. I know it's a lot of details, but you can save the forms, and you can include the current values, and you can give it a name. And see, when I am here in this view, and I was using the fields, right? I was using the fields, but you have also forms. And you have different forms. I have my forms. These are the forms I saved. So for example, just to show you, I don't know, an anti-inflammatory national compound targeting MAPK, for example, right? And you see, I group them. You can group fields very easily. You just move them like this, and you create groups. So you can do this. Azoles with fungicidal activity, carbon nanotubes. So this would be most probably, yeah, that's a text search. You can just move the fields like this. So if you build the fields, you can move them like this as well. And you see here, I'm using OR, but I'm also using the other operator, which is near. Operator near tells me for text searches that carbon nanotube should be not more far away than 3 words. In this case, I can change it. I want carbon nanotube maximum 3 words apart from one of those, because here I have OR. So you only need to get the logic of it, which is quite nice and easy and transparent. Once you get it, this is really very, very helpful. The last thing I want to show you in forms, and I'm finishing, you have Reaxys forms, and these are like collection of fields. So we created, for people who don't know which fields to use, if you are in reactions, these are mostly fields that people use, nothing special. But what is really special are Reaxys targets and bioactivities forms. Here you will see that, for example, Kako2 permeability, this is not only fields which are already collected for you, and you can just click and enter part of your structure or the structure. And fields are necessary, but also you have them pre-filled. Like cell lines, you already have pre-filled Kako2 cell line. And you see measurement parameters, which are the parameters that are normally measured for this. So it's enough for you to enter part of your structure, click search substances, and you are done. Selectivity profile. You remember I talked about selectivity. It's very difficult to find selectively active bioactive compounds. In this case, it's very easy. I want to find compounds very active on COX-2. So that's more or equals, I don't know, let's put 8. You remember px is 1 to 14, right? So I have very active compounds on COX-2, maybe 9, why not? And we compare it to COX-1 and less than equal. You see, this is already prepared. Let's say 5. And click on substances, very easy. So I have my 59 substances, but from this view, I'm not seeing this selectivity. What do I need to do? Bioactivity visualization, right? I was expecting 2 columns, and I see on my navigator that there are 2 columns full of data. I can also see it here, but these big dots. And there is some other forms of my targets, which I don't want. So what I need to do, I just want to select these 2 columns, click on 3 dots, and we need to select it. And the second thing I need to do is click on 3 dots and sort by activity. And my selectivity study is done. And export the whole thing to Excel and analyze this. And you see how easy it was, right? And you can go and view all the details, or you can just, as I said, export everything to Excel and analyze. So I think I'm over the time, 8 minutes, and sorry for that. So I think for now, it should be enough. I think it should be enough for the first time. Once again, I remind you my email address, p.golkiewicz@elsevier.com. I think many of you that are here on this training know it. But for those who don't know, please, please, please. I'm your person. I'm your support. I wanted to show you different things. There is more. We can look at absorption data. We can look at viscosities. We can look at physical-chemical properties, different types of reactions. We can look at catalysts. I didn't have time for it. Let me know what you want. If you just have a question or you would like to prepare and organize a training for your group, lab, departments, with the specific topics, we can do this.